Hello everyone.
Myself Balamarahan. Today we focus on the topic of Gaussian process. First of all, we need to focus on the need of Gaussian process. The Gaussian process is generated due to the thermal noise. The thermal noise in any electronic devices which is produced by the random movement of electrons due to the thermal agitation. It can be closely modeled by a Gaussian process. The higher the temperature, the higher the velocity of electrons. In general, the current is due to the movement of free electrons. The total current generated by all the electrons, which is generated by the thermal noise. The thermal noise is due to the movement of free electrons. It can generate a small piece of current, either it is a positive or negative. Therefore, is the sum of currents of all these current sources. Let y be a random variable find by integrating the product of random process x of t, caps x of t, for a time period of t is equal to 0 to t is equal to t, capital T, time period capital T, and some function g of t is given by. Therefore, the y random variable is equal to integral over the limit 0 to capital T x of t into g of t dt. As you are well known about the concept of random process, random variable, random process, mean, variance, standard deviation, autocorrelation, cross correlation, covariance. These are the stochastic parameters. So why we focus on the Gaussian process? In specifically for thermal noise. Thermal noise is adaptable for a Gaussian distribution. Therefore, the Gaussian random variable be a Gaussian random process. The weighting function in above equation is such that the mean square value of the random variable y, it is finite, and if the random variable y, as I told earlier, y is a Gaussian distributed random variable for every random value g of t, then the random process x of t is said to be a Gaussian process. The random variable y has a Gaussian distribution and their respective PDF, probability density function, as the form of f, the random variable is capped y of small y, the random process capital Y of random variable small y is equal to 1 by square root of 2 pi sigma y, the variance sigma y, in exponential of minus of y minus my whole square by 2 sigma square y, whereas m suffix y is the mean of the process, whereas sigma y square is the variance of the random variable y. For this slide, figure indicates the normalized Gaussian distribution. So how the Gaussian distribution can become a normalized Gaussian distribution, whereas the mean is 0 and the variance is 1. So by this distribution, the current is generated due to either in a positive direction or negative direction. Therefore, the random variable is a Gaussian random variable and it satisfies the Gaussian distribution. This flow, this diagram indicates the Gaussian distribution. Therefore, the thermal noise is generated from the electronic devices. Definitely, it follows the Gaussian distribution. Therefore, that it is modeled by a Gaussian random process. So the Gaussian random variable y is a normalized, the mean is 0 and the variance is 1. Fy of y, for this previous equation, you can apply the mean is 0 and sigma y square is equal to 1. It can be reduced as Fy of y is equal to PDF is reduced as Fy of y is equal to 1 by square root of 2 pi exponential of minus y square by 2. Now let me focus on the advantage. What are the advantages? It is a measurable one. Analytic results are possible and the real-time one. The physical phenomenon are often such as the Gaussian model is appropriate one. Now let me see about the properties of Gaussian random process. X of t is a Gaussian process, then this set of random variable is jointly Gaussian for any nth event, where with their PDF completely specified by the set of means mx of ti suffix I is equal to exponential ensemble average capital E of x of ti, where I varying from the different instants 1, 2, 3, etc. n. And what about the set of covariance functions? Cx of tk comma ti is equal to ensemble average of the random variable Gaussian random variable x of tk into the mean of the process m of x of tk into x of ti minus m of x of ti, whereas k and I vary from the different instants 1, 2, 3, etc. n. The second property is that the set of random variable x of ti is uncorrelated. For their condition, the I value and j, I and j are the random variable. Gaussian random variables are I and j are not equal. For this moment, the covariance is equal to Cij is equal to 0, whereas x of ti are independent. The third property indicates a Gaussian random process is stationary. When we are called as stationary, then this process is said to be a strict sense stationary process. The Gaussian process is said to be the strict sense stationary random process. The fourth property deals with a Gaussian process x of t is passed through LTI filter. What is LTI? The linear time invariant filter. Then the random process y of t at the output of the filter is also a Gaussian process. So these are the some properties behind to the Gaussian random process. Thank you. Patient listening. Thank you.